All right, you guys, so we're going to go ahead and do lesson 5.6 in this case. It is graphing inequalities. So just a few things I want to go ahead and go over here with graphing inequalities is our symbols. So in this case, we are going to be having our less than, greater than symbols, and less than or equal to or greater than or equal to symbols. Only thing different between these two is obviously the line. If you have in this case a symbol where it's just a less than or a greater than symbol, your line will be dashed. In this case, it will be dashed. And if it does have a line on the bottom or an equal to sign on the bottom, it is going to be solid. All right. So let's go ahead and get started here, guys, with example 1. There's a total of 3 examples here. So we're going to go ahead and graph inequalities. Inequalities here are linear, which means that they are going to follow the format of a y equals mx plus b. In order for us to graph, we need to identify m, which represents the slope, and we need to identify b, which in this case represents the y-intercept. Obviously, the only thing different from the linear equations or slope-intercept in this case is our equal sign. So it's not going to be an equal sign. It's going to be one of these inequality symbols. So let's go ahead and get started here with example 1. In this case, guys, if we want to go ahead and graph the inequality, our goal in this case is to actually isolate our y. So I do have to move everything to the other side and leave the y alone. So in order for us to do that, I am going to be adding a 5x to both sides and 5x on this side. So that's going to give me a 3y is greater than or equal to a 5x plus 9. All right, once again, we want to go ahead and isolate the y. So in order for us to leave the y alone, I will be dividing both sides by 3. In this case, because we divided by a positive 3, nothing's going to happen to the inequality symbol. So we have our inequality here of y is greater than or equal to a 5 over 3x plus a 3. All right. So this is the equation we are going to be using in order for us to graph. Now, once again, in order for us to graph, we do need to identify 2 things. We need to identify our slope, and we need to identify the y-intercept. In this case, guys, the slope is the number next to our variable x. So in this case, our slope here, this is going to be our slope, is going to be 5 over 3. Slope in this case, guys, if you recall, is rise over run. So in this case, we're going to be rising 5 and running 3. And since this is positive, it's going to be our linear equation in this case is going to be in this format. It's going to be a solid line, and it's going to be going up and right. Okay, so that's the slope. And then that leaves in this case the 3 as our y-intercept. So in this case, whenever we're graphing, we do start off with the y-intercept. So that will be the point 0, 3, and then we'll go ahead and do the slope from there. So let me go ahead and draw my graph here. Yeah, let's do it in black. So a little bit more up. All right. So this is x. And I hope I have enough space. This is y. So let's go ahead and do some labeling. 1, 2, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, obviously. All right, so let's go ahead and start once again by plotting our y-intercept. Y-intercept in this case, guys, is always going to be on the y-axis. So this is going to be 0, 3. We find it here. And from there, we're going to go ahead and graph using the slope. In this case, the slope is 5/3. So that's telling me that I'm going to rise 5 and run 3. So in this case, it's going to be 1, 2, 3, 4, 5, and then 1, 2, 3. So our point in this case is going to be found there. And in this case, guys, whenever you're graphing, all you need is 2 points. So let's just go ahead and connect those two. And in this case, since we do have an equal sign, it is going to be a solid line. Now, once you graph in this case, graphing is the easy part here. What we want to go ahead and do in this case is we want to go ahead and see whether there's going to be shading above or below. All right. And the way we find this in this case, guys, is we actually need to choose a point, any point in our graph here, in our graph, and basically plug it into the equation. If the statement in this case is true, then we would be shading in the direction of the point. And if it's false in this case, it would be on the opposite. So in this case, guys, I do want to go ahead and easiest point for you guys to choose is the point 0, 0. So in order for us, once again, for us to check what direction we're going to go ahead and be shading here, I want to go ahead and choose a point. So our checkpoint is going to be the point 0, 0. So in this case, I will be substituting wherever I see an x in my original equation, or I could use this one as well. Wherever I see an x, I'll be putting a 0, and wherever I see a y, I'll also be putting a 0. So I could use this one in the yellow or this one here. It doesn't matter which one I use. But I'm going to go ahead and stick to the original one. So I have a negative 5x plus 3y is greater than or equal to 9. All right, so let's go ahead and substitute. I have a negative 5 times 0 plus 3 times a 0 is greater than or equal to 9. So negative 5 times 0 is 0, 3 times 0 is 0. So that's basically telling me that 0 is greater than or equal to 9. In this case, is this statement true? Is 0 greater than or equal to 9? And in this case, guys, that actually is false. So because it's false, we're not going to be shading in the area where 0, 0 is. We're actually going to be shading above. So in this case, that would be my answer. Okay. So once again, shading above, that would be our answer.